In this video, we present the privacy protection initiatives and experimental demonstrations within Dynamic Map 2.0, an information coordination platform for cooperative automated driving currently being researched by Nagoya University. Autonomous vehicles are equipped with high-precision sensors to understand their surroundings while driving. However, onboard sensors alone have limitations, such as blind spots created by obstacles or other objects. Consequently, achieving safe and comfortable automated driving relying solely on the vehicle's own sensors is a significant challenge. By utilizing Dynamic Map 2.0, which shares information captured by surrounding vehicles and roadside sensors, we can compensate for these blind spots. For instance, cooperative roadside units currently under development at Nagoya University can be installed on utility poles and traffic lights. These units share object information including the position, speed, and size of pedestrians and vehicles to Dynamic Map 2.0. Vehicles can then receive and utilize this roadside information to navigate more safely. Vehicles also contribute information back to Dynamic Map 2.0. We call the data regarding the vehicle's own driving status Ego Object Information. Currently, this information includes a system-managed ID, a timestamp, and location data. By sharing its own location, a vehicle can, in turn, receive more accurate and appropriate information about its surroundings. However, sharing ego object information as is carries privacy risks. For example, if data containing the same ID is continuously recorded, malicious users or attackers could trace long-distance driving routes. Even without physically following the car, they could identify departure and arrival points, infringing on the vehicle owner's privacy. The primary cause of this vulnerability is the vehicle transmitting data using a fixed static ID. To address this, we implemented a system using multiple disposable IDs, which we call pseudonym ID. By preparing multiple pseudonym ID per vehicle and switching between them, we prevent long-distance tracking from recorded data. These pseudonym ID are managed centrally within Dynamic Map 2.0 to ensure that no two identical IDs are active simultaneously. Next, we will present an experiment using these pseudonym ID conducted in September 2025 in the Kashiwanoha area of Kashiwa City, Chiba Prefecture. For this test, a manually driven vehicle was equipped with Dynamic Map 2.0 compatible hardware and sensors. The system is designed to switch the pseudonym ID upon entering and exiting intersections equipped with cooperative roadside units. This footage shows the operation while turning right at a single intersection. The star marks indicate the assumed locations for ID switching. You are seeing the actual driving footage alongside the data shared on Dynamic Map 2.0. At this moment, the vehicle is sharing ego object information with the pseudonym ID 519351. The system tracks and displays the trajectory while the same ID is present. As the vehicle approaches the intersection, the pseudonym switches and the tracking trail is intentionally broken. Subsequently, as it completes the right turn and exits, the ID switches again, further breaking the tracking trail. Let's compare these results with a scenario where the pseudonym system is not used. Without pseudonym ID, the ID never changes, making it easy to trace the vehicle's entire route. With a pseudonym system, even if someone tracks ID 91928, it is difficult to determine from this data alone whether the vehicle went straight or turned at the intersection. Using this mechanism helps protect the privacy of each vehicle. Finally, here is the footage from an experiment confirming ID behavior while driving through 4 consecutive intersections equipped with cooperative roadside units. We verified that the pseudonym ID successfully switched upon entry and exit at each intersection. Dynamic Map 2.0 strives not only for driving safety, but also for the security of information sharing itself. Today, we demonstrated a mechanism to protect the privacy of participating vehicles using pseudonym ID. For more detailed information on this initiative, please refer to the link provided.